Hello friends, today we are going to learn about memory management in C. And in this we are going to see following topics. First one is basics of pointer. Here we will see the definition of pointer, how it will be point to the memory location. The second thing is pointer to an array. Here we are going to see how we can access different elements of the array using the pointers. Pointer arithmetic. Here we are going to see what are the arithmetic operations that we can perform on pointer and why it is valid and why other are invalid. Memory location, allocation. Here we are going to see toward how to create 1D array, how to create 2D dynamic array and all the stuff. And finally we are going to see some errors while using pointer. So let's start with basics of pointers. To understand the basics of pointer, we need to assume that the array is organized as a 1D array. The index value of array is called address, and each location is a 1 byte long. It is a 1 byte long. When I create a variable integer a, for a time being, let us assume that integer requires 4 bytes of memory. There are two types of integer. One is a short integer, one is a long integer. In modern computer, most of the compiler, when we use integer, by default it uses the 4 byte. But in some compiler, it uses the short integer, and that will be a 2 byte. For the time being, we are assuming that GCC compiler gives 4 byte of memory. So assume that here integer is required 4 byte of memory. So what does it mean is, when I create an integer a variable is created a here. It will point to the first memory location, and from that particular location 4 byte will be reserved to store the integer value. Okay. Now I want to create a pointer p that will point to a integer variable. Now let us assume, if I say p equals to n of a. Now when you create a variable p, for a timing, let us assume the compiler can allocate up to 4 GB of memory. If it is allocating up to 4 GB of memory, the size of the pointer will be 4 byte, irrespective of what it is pointing to. Whether it is pointing to integer, whether it is pointing to character, whether it is pointing to float, it will not make any difference. So here, let us assume, for a time being, let us assume a compiler can allocate up to 64K of memory. Okay. In that particular case, the size, in this particular case, the size of the pointer will be 2 byte. Pointer size. So when I say pointer to is pointing to a Now let us assume here the first location of this is 1000. When I create a variable p, that is also a pointer. Now it is also a variable. It will be allocated some memory here. As I told, it is a 2-byte memory. So it will require 2-byte memory, 64-bit address is there. That is why we require a 2-byte of memory. That is assume 2-byte memory location is there. Now p is pointing to this particular memory location when I created this variable. After that, when I write p equals to %a, that is address of a, at that time address of a, the first location of address of a is 1000. So here 1000 will come. So this is the way we create the variable. Now let us assume in other that if it is a character C and I create a character pointer CP and CP equals to AND of C. Similarly, let us assume C is somewhere here. Character requires only 1 byte of memory. Okay. So let us assume this is 1050. Now CP I created new variable. It could be anywhere. So let us assume it is here 2 byte of memory. So in this particular place 1050 will be allocated after the execution of second instruction. Now this is the basics of pointer. Now we are going to see how pointer can be useful to access the array element. So now let us assume I create an integer a array of 10. After that I create a pointer to an integer. Now what I want is when I create an array, let us take this example, array of 5, let us assume. It will have a 0, 1, 2, 3 and 4. For a timing, let us assume the 0th location is at 1000. Then 1 will be location at the 0th element will be from 1000, 1001, 1002 and 1003. The second element will start, that is second element is the first a of 1. That will be start from 1004. So the first location of the address is 1004. After that, the second location will be 1008. Third location will be 1012, and the fourth element will be 1016. Okay. So now if I want to point it to the first element of the array, so what I will do, can write like a p equals to AND of a0, and even if I write a, this a will be translated in this format and then it will be pointed to a. So even if I write a or a of AND of a0, sorry, both are equivalent. Now let us assume I want to iterate over all the elements. In this case, what I will do, I will write a while loop. While for a timing, let us assume I is less than 5. We are assuming the number of elements. What I want to print the content of P. That is actually means I want to go to the location pointed by the P and print that particular value. Okay. So I am going to use printer function. Percentage D is indicating we are printing a decimal digit, a decimal number. Now what we are printing is content of P. That is, here we are going to write star. This star is a dereference operator, which means that, and we should read it like content of P. If I write P, it will be read as a content of P. Then P equals to P plus 1, I equal to I plus 1, where initially I equals to 0, and finally we will hold. Now what will happen to this particular equation? This will be translated in the form of P equals to P plus size of int into 1. So that will be equals to, initially the value of P is 1000. What is the size of the integer? 4 plus 1 here we have written, that is into by 1. So it will be 1004. Now if you look at this particular values, they are coming same. Okay. So in this way it will keep incrementing. Now if I directly want to, instead of iterating one by one, can I directly point to the third element using the P? In that case, what I can do, I want to move to the third element, and then I want to print the content of that. After that, obviously I need to write the printf statement. Percentage D and then I need to write content of P plus 3. Now how this P plus 3 will be converted is, P, the value of P is 1000 plus 3 into size of the integer is 4. That will be equals to 1000 plus 12 equal to 1012. What is the address of third element in the array? 1012. Similarly, we can access any element in the array using the pointer. Now, how to create a dynamic array? For that, what we are going to do is, we are going to create an array, a pointer to an integer. We are not going to see all the functions as they are not that important. The important is the concept here. What I want is, I want to create a memory location, and for that we are going to use malloc. Now here I need to specify the size of the block I need to create. That will be some integer value. So now let us assume I want to create the array of 10. So what I need? An array of 10 elements. How much memory is required for the 10 integer elements? As I told that the size of the integer may vary depend upon the compiler to compiler. I can directly write 2 or 4, but it may run for some compiler and may not run for the other compiler. So the best way to do it is multiply 10 by size of integer. Now this much memory is allocated. That is 10. What is it? 10 into 4, that will be 40. Even if I directly write 40, it will work. But the problem will be, if my integer is occupying less than 4 byte of memory or more than 4 byte of memory, in that particular case this code may not work properly. Now after this is allocating only memory, size of the memory. Now what should be the content of the memory, that also need to be specified. So what we are going to do is we are going to specify it is, and it will hold the integer values. Okay, so this will be my malloc statement. Now how to create a 2D array? 1D array is easy like this. How to create a 2D array? In that particular case, what we need to do is, now first of all we need to understand what is a 2D array. Okay, when we are creating a static 2D array, means a simple 2D array with constant, it will work directly. It has a different mechanism. But when we are creating a 2D array using the pointer, how it will be done? First thing that we need to create is let us assume int a 2D. Now I want to create 2D array. Then for that I need to create pointer to one pointer. Let me explain that thing. So first thing that we are going to do is we are going to create memory location a equals to malloc. I want to create, let us assume I want to create 10 plus 10. Then 10 into size of, you will see what should be come inside. What should become here is int pointer to a pointer. Now how this particular memory location will work, that we have to understand. What we are going to do is we are going to create an array of pointer, and each pointer will point to one array. The size of the array could be different, but in this particular case we are going to use the same size for the array. So all these elements are also pointer. So what is this? This is a pointer. So this we have to create. Size of 90 pointer. We always use this size of operator to make sure that it runs across the compiler, across the platform. Okay. Now what this particular function is done? It created pointer to an array of pointer to an array. So it is pointer, but it is not pointing to anything right now. All of them are null. So what I need to do now, I need to create the pointer for everything. So for I equals to 0, I less than 10, I plus plus. Now I need to do a of I equals to integer star malloc size of 10 into size of integer. So once I write this thing, for when I equals to 0, it will create an array of 10 for I0. When I become 1, it create the array of 10 for I equals to 1, and so on. So this is the way we are going to create a 2D array. So now we are going to see what is dangling pointer and what is memory leakage. For a dangling, let us assume that I create an array, a dynamic array, and finally I want to create an array of 10. But it is dynamically created. whatever the memory is created dynamically need to be freed manually by the programmer. It is not automatically freed in C or C++. We have to manually free it. For that we are going to give a pointer A. So we created an array that is pointed by A. But at later point of my time, again I created a new block, and this now A is pointing to the new block. So what will happen to the first block? I created a block, I didn't free that memory, and no pointer is pointing to that particular block. In some cases, some pointer is uh, pointing to that block, but we are not able to reach to that pointer. In both the cases, what is happening is we are not able to access this particular block of memory, but this memory is occupied by the program. This kind of scenario is called memory leak. Now what should we do actually? Whenever we want to create a new block, and that need to be pointed by the new array element A only, before doing that thing we should free A, and then we should create a new block malloc. In that case there will be no free memory leakage. And finally we are going to see what is dangling pointer. Now let us assume there are two pointers AB and BP. Both are pointing to the same block of memory. After some time I write free AB. So what will happen? This particular block of memory will be destroyed and it is the free memory now. But BP pointer is still pointing to this particular block of memory. So when BP try to access this particular memory, what will happen? Now let us take an example that you have a house roadside and you went to the US. In between, government want to widen the road. They send some notice to you. You are not there. So they destroy your house and widen the road. When you came back, you have the exact coordinate of your house. You went to that particular coordinate, and you see that there is no house. But as you have the exact coordinate of your house, you try to sit on the road in the main road highway and disturb the traffic. What will happen? People will throw aside the road. So similarly, if a program is trying to access a memory location which is not allowed to be accessed by that particular array or by the particular pointer, in that case what will happen? Generally we will see in many compilers segmentation fault. Most of the time the segmentation fault happens because we are accessing a memory location which is not allowed to be accessed. Many reasons could be there, such as like dangling pointer. The other reason could be array index out of bound, and many other elements are there. You are having a null pointer, and then you are trying to access that memory. So all these things come under the segmentation fault. Okay, so these are the basics of memory management in C. Thanks for your support.